I'm sure you've been at the beach at some point and you put your towel down, you play around at the beach for a few hours, and the next thing you know, your towel's going out in the water. You didn't move your towel. What happened was the water came to your towel, right? Well, this is what the tides are about. The tides are the twice daily fluctuations in sea level along the coastline due to the gravitational pull of the moon and the sun on the earth. Everything that has mass has gravity. In other words, it attracts other things. The pencil that you have has mass, it has gravity. You have mass, you have gravity. Your automobile has mass, it has gravity. Of course, the moon has mass, it has gravity. The earth has mass, it has gravity. And the sun has mass, so it has gravity. So this is the twice daily fluctuations in sea level along the coast because the moon and the sun are pulling on the earth. The most obvious way you're going to see this is with a fluid body like water because it's so pliable. Does it happen with the land? I think there is some evidence that it does happen with the land, just not nearly as dramatically as what happens with water. The moon is about 240,000 miles away from our planet, just slightly less than that, but about 240,000 miles away. And you know the sun is 93 million miles away. You would think that because the sun is so much bigger than the moon, that its gravitational influence on our planet would be greater, but that is not the way it works. The moon has greater gravitational pull on planet Earth, despite the size differentials, because it's so much closer to the Earth. At the same time, they are both pulling on us. Look at this diagram. First of all, notice on the left-hand side, you can see the sun. Then notice the Earth right in the middle, and pay attention to that dotted line that indicates our orbit, our revolution around the sun. Remember, we make 365 and a quarter rotations for every single revolution. That's what gives us our year. One time around the sun is a year, and during that period of time, we're going to make 365 and a quarter rotations. Okay? Now look at the moon. The moon goes around us just like we are its sun in a way. And if you look, it goes around us from a northern hemisphere perspective counterclockwise, just like we go around the sun counterclockwise from a northern hemisphere perspective. Now look at the different phases of the moon. There's the new moon, the first quarter moon, the full moon, and then what this diagram calls the last quarter moon, which is also sometimes referred to as the third quarter moon. I want you to understand this before we move any further. The moon makes one rotation with every full revolution. We make 365 and a quarter rotations with one revolution. The moon is only going to make one rotation with one revolution. By the way, Mercury does this with the sun as well. That means that we are only going to ever see one face of the moon. That's it. I think you know what the full moon is. It's when there's the full round disk in the sky. You probably understand what the two quarter moons are. That means you can see half of the moon. The new moon is when you cannot see the moon. Now, of course, it exists. It's just that because of its orientation between the sun and the earth, we cannot see it. I've just highlighted with those two yellow arrows, the new moon and the full moon. That's where we are going to start. It takes the moon about 28 days, depending on how you're counting it, but about 28 days to make one full revolution around us. So a moon year, if you want to call it that, is about 28 days because it goes around us over that period of time. And if you look, you can see where the new moon is and where the full moon is. Okay? Now notice this. I just put this red line on there. You can see that when the moon is in the new and the full phases, notice that the sun, the moon, and the earth are all aligned. And what that means is that the moon and the sun are going to be pulling on us, on our water, on our tides, together in concert with each other. When that occurs, when the moon is in the new and the full phase, we are going to experience our greatest tidal fluctuations of the month. We call these the spring tides. It has nothing whatsoever to do with seasons. This has to do with the water kind of springing forth. So when the moon is in its new and full phases, what's going to happen is we enter into our spring tides. The spring tides are our greatest tidal fluctuations of the month, which means the high tides are the highest, the low tides are the lowest. This is because the moon and the sun are pulling along the same line on the earth in concert with each other, okay? And that means that if you are at the coastline, what you're going to see is this. You're going to experience the highest tide, and then the water's going to go out and you're going to experience a low tide. And then a little bit later, you're going to experience another very high tide, and then you're going to experience under the low tide over a 24-hour period. Those are the spring tides. I took this picture in Maine. If you look at that orange arrow, you can see it's that point of that clump of vegetation that's on that little landmass, kind of like a little bit of an island there. This was during low tide. The East Coast tends to have much greater noticeable tidal fluctuations because the offshore landscape is flatter. On the West Coast, it tends to be steeper, as we're going to see when I talk about submergent and emergent coastlines. Well, 6 hours later, taken from the exact same little bridge, there we go. That's high tide. That's low tide. That's high tide. And this was during a full moon phase. So you can see massive tidal fluctuation. This is directly the result of the gravitational pull of the moon and the sun on our planet. Isn't that awesome in a lot of ways? Okay, the Neap Tides occur when the moon is in its first and third or last quarter phases, which you can see I pointed out with the yellow arrows. When the Neap Tides occur, notice what's happening. The moon and the sun are no longer pulling on the same line on the earth. So that means that the moon, which has greater gravitational pull on us, is pulling at a right angle from the way the sun is pulling on us. The result of that is that we have our smallest tidal fluctuations. Now look, the moon is going to pull the water in one direction. The sun is still going to pull, it doesn't completely disappear. The sun is still going to pull the water in a different direction. The result of that is that the water doesn't bulge out nearly as much. So as we rotate over 24 hours, we will rotate into high tide, which will not be very high. Then we'll rotate into low tide, which will not be very low. Then back into another high tide, which will not be very high. And then back into another low tide, which will not be very low. So the difference between the movement of the water on the coastline is much less when we have the neap tides because what's happening with the sun and the moon.